More than 95% of cloud security engineers are building the wrong projects. I know this because I used to think a static website built on Amazon S3 would get me hired, until I discovered exactly what hiring managers are actually looking for in 2025. I'm Suleiman, I've worked in tech for a decade, and I've built my own AI cloud security consultancy. And through my academy, I've helped over 400 students learn cloud and AI with my first principles blueprint for engineers. And in this video, I'll reveal the best cloud security projects to get you hired fast, starting with project number 1, Secure File Vault. When you're working in a team and you're sharing sensitive financial and client information, there's always that nagging concern: unauthorized access. What happens when files get into the wrong hands? Damaged reputation, potential fines, and loss of client trust. So, what's the approach that actually delivers results? Let me show you how I approach security from first principles. So when I have a problem or I'm trying to build an actual solution for a client, I always ask, what are we trying to accomplish? Here, we want information flowing between authorized parties whilst keeping everyone else out. Now, to ensure we achieve this, we have to address 3 fundamental questions. What exactly are we protecting? Who should have access? And how does the access change over time? This leads us to 3 requirements that will form the core of our project. Your sensitive files need proper encryption. This is a non-negotiable. Using Amazon S3 with server-side encryption, it means that your data remains protected even if other security layers fail. If someone somehow accesses the underlying storage, they'll face encrypted data that it can't interpret. I found that that is typically where most security breaches happen. You'll need to verify who someone is, so the authentication, and what they are allowed to see, the authorization. AWS services like Cognito handle the verification process, while IAM policies enforce the least privilege principle, giving people access only to what they absolutely need. Now, when these controls work together, you get a system that's both secure and functional. Now, without visibility into who's accessing what and when, you don't have complete security. CrowdTrail records every action, creating a reliable record of all file interactions. This visibility means you can detect unusual patterns and respond quickly to potential issues. Now, let's build our secure file sharing portal, starting with step number 1, creating an S3 bucket with server-side encryption. This is specifically designed to handle sensitive documents whilst maintaining high availability. And when we enable server-side encryption with AWS KMS keys, we are adding a critical protective layer. Every file uploaded to our system automatically gets encrypted before it even lands on the storage media. Users don't even notice that this happens. The encryption is completely transparent to them. And the beauty of this approach is that our files remain protected at rest until an authorized user needs them. And at that point, only then the system will decrypt them for legitimate access. Now, with our storage foundation secure, we now focus on controlling who can access what. This is where we design IAM roles that match our organization's structure, creating specific profiles for viewers who only need to read documents, editors who need to make changes, and administrators who manage the overall system. Now, each role is carefully crafted to provide only the permissions absolutely necessary for that specific job function. We take it a step further by scoping these permissions to specific folders or file types whenever possible. Now, for extra added security, we can implement IAM conditions that can restrict access based on factors like time of the day, IP addresses, or whether the user is using multi-factor authentication. And now, as our team evolves, we audit and update these permissions to ensure they remain appropriate. But that is not enough. We also need a way to reliably verify who's accessing our system. We'll use Amazon Cognito to implement a registration flow for users. Cognito handles all the complex identity verification and will enable multi-factor authentication for that crucial extra layer of security. And when users log in, Cognito doesn't just grant the access, it issues temporary credentials that are specifically aligned with their IAM role. These credentials only work for resources they're authorized to access and automatically expire after a short period. And this creates a seamless yet highly secure authentication process that's difficult for attackers to compromise. Now that our security is in place, we have to design a clean interface that brings all of it together. If it's hard to navigate, nobody will use it. And when users want to upload new files, a simple drag and drop area makes it effortless. And as they work with documents, all downloads happen through pre-signed URLs that verify permissions before allowing access. Now, if they need to share a document with a colleague, they can do so through a permission management system that clearly shows who has access to each file. So we can use AWS Amplify to host our UI, so our web interface, which is beautifully integrated with Cognito and S3 to build this, because our users need to see where they're dragging their files to. Something to think about is that cloud security isn't just about prevention, it's also about visibility. That's why in step 5, we implement CloudTrail to record every single action that happens with our S3 objects. So when someone uploads, downloads, or even shares a file, we capture who performed that action, exactly when it happened, and where they were connecting from. These logs are stored securely in their own dedicated bucket where they can't be tampered with. And we set up automated alerts that trigger when suspicious patterns emerge. For example, someone downloading an unusual number of files or accessing the system at 3 or 4 a.m. Our system will also perform regular log analysis to help identify normal access patterns versus potential security incidents. We also ensure our logs are retained according to compliance requirements, creating an audit trail that we might need in the future. Now, there's an overlooked cloud security risk that we have to address: data that stays in your system for too long. That's why we, in step number 6, will set up a data lifecycle by defining retention periods based on both sensitive and business needs. Once we have these policies in place, S3 lifecycle rules automatically move older files to cheaper storage tiers to optimize for cost. And when files reach the end of their retention period, our system will automatically delete them, reducing both storage costs and also potential compliance issues. Now, for regulatory requirements, we can implement special handling for files that need longer retention periods. And the system provides regular reporting on the status of data across its lifecycle and verifies compliance with retention policies. This way, we ensure that data doesn't live forever, reducing both the cost and the risk over time. Can you see how when you set out the core requirements for a problem and then break it down to first principles, you create a system where each component has a clear purpose and delivers real benefits? And most importantly, your entire solution directly addresses real business needs rather than theoretical threats. And when you think about cloud security in this way, it becomes a competitive advantage and businesses will desperately want your expertise. And that's not the only critical cloud security challenge that businesses face today, because in modern cloud environments, the sheer volume of resources like S3 buckets, EC2 instances, databases, and way more creates a specific problem. Manually tracking all security configurations is impossible. So, project number 2, we're going to build the Cloud Security Scout. But first, we have to approach the problem from first principles, and again, we have to ask the questions. What are we really trying to achieve? At its core, we want to ensure that every single resource in our cloud environment adheres to our security baseline, regardless of who created it or when they created it. And we can't just set it and forget about it. It has to be continuously monitored because resources are being created and modified all of the time in our cloud environments. Next, let's set our core requirements for this project. And this time we have 4. And starting with number 1, comprehensive discovery, which just means finding all resources across your environment because you can't secure what you don't know. This discovery process must be automated and thorough, identifying resources across all accounts. Number 2, consistent evaluation. We have to ensure that each resource is checked against the same security baseline every single time, and we'll set this baseline ourselves. And number 3, timely protection. The window between a misconfiguration appearing and being exploited can be remarkably short, sometimes just a few hours. So we have to shrink that window of vulnerability by detecting issues quickly. And finally, requirement number 4, prioritize remediation. This is like triaging. We have to focus attention on the highest risk issues first. Not all security findings are equal. Some represent immediate threats, whilst others are more theoretical risks. Now, here is how we're going to build it. Starting with step number 1, identifying the high impact vulnerabilities. Examples of this include S3 buckets that allow public reads or writes, security groups that open critical ports to the entire internet, and RDS databases lacking encryption at rest. It's very simple. Here we are applying the Pareto principle to security. Roughly 20% of security issues will represent 80% of your risk. By focusing on high impact vulnerabilities first, you get the most security improvement for your initial effort. And this is the first first principle thinking in its essence. What problems would have caused the most damage if exploited? Next, we can leverage AWS Lambda to run our security checks without having to manage any servers. Using Python and the AWS SDK, we write the code that systematically examines our cloud resources. For instance, when checking S3, you want to list all your buckets and examine their access control policies to see if they are public. For security groups, you want to list every rule and look for rules allowing inbound traffic from the internet on sensitive ports. For RDS, you want to verify that each database is encrypted at rest. Now, having programming checks in this way ensures consistency and scalability. We don't want to do this manually. This way, we're directly addressing the discovery and the evaluation requirements, ensuring nothing is missed due to human error. For step 3, as you know by now, cloud security isn't something that we just fix once. It's an ongoing process. So we're going to use Amazon Event Bridge to schedule our Lambda function to run automatically at regular intervals like every day at 2 a.m. And if a new misconfiguration appears, we'll discover it really quickly. After each scan, step number 4 will store the results in DynamoDB. This lets you track the changes over time. And then from there, you might notice over time a particular team repeatedly opens up port 22 to your entire internet. You can then send them the highlight trends and educate the team on the most secure approaches. Now, this gets you in the mindset of not treating cloud security incidents in isolation, but instead you're identifying reoccurring problems across the business. From first principles, you are acknowledging that security improvement requires understanding and not just what's gone wrong, but why it keeps happening. Now, with security issues that are urgent, such as an open database port accessible to just anyone, step number 5 means we are going to integrate SNS or Slack notifications to alert security teams. By prioritizing these alerts, we make sure that the most severe risks are addressed immediately, directly addressing one of our 4 core requirements: prioritize remediation. From first principles, we understand that not all risks are equal, so a tiered alerting approach ensures critical issues are fixed straight away. Now, with the automated assessment tool set up, is that all? Well, no, because at step number 6, we now have to iterate and expand with new checks. For example, you might look for IAM users who lack multi-factor authentication, or you might verify that EBS volumes are encrypted. Now, this iterative approach, starting with the biggest risks and then expanding, is a direct application of first principles thinking. Address the basics first, then refine and extend your coverage as you gain confidence in your automation. Here, we are acknowledging that the perfect cloud security is impossible from day one. By starting with high impact issues and gradually expanding, you create a sustainable improvement process rather than an overwhelming project that tries to do everything at once. You have to see cloud security as a continuous journey and not a destination. So this project will help you get hired fast because it shows you that you can do way more than just follow basic rules. You understand what really matters for security in your cloud setup, and most importantly, you understand why. And as cloud services change, you can easily adapt your security approach. So instead of checking security once in a while by hand, i.e. manually, you've made it an automatic, ongoing process that keeps up with fast development. Your system finds problems, evaluates them consistently, catches issues quickly, and helps fix the most important things first. And in 2025, companies are continuing to adopt container-based applications, which means they are packaging their software into units called containers using technologies like Docker or Amazon ECS. These containers run consistently across any computing environment, allowing for seamless deployment to the cloud. But here is the problem. They often prioritize speed and portability at the expense of security. And when you consider that 87% of container images contain at least one high or critical vulnerability, container security obviously shouldn't be an afterthought. So we're going to build project number 3, the Container Security Falcon. But first, we have to understand container security at its core. And again, applying the first principles and stripping away the complexity, there is 2 essential areas that we have to focus on: verifying what goes into the container image and restricting what the container can do once deployed in the cloud. Now, there is 4 core requirements for this project. Number 1, we want to minimize the attack surface. which means including only what's necessary in your container to reduce total number of vulnerabilities. Number 2, the principle of least privilege ensures containers run with only the permissions that they need to function and nothing more. What this does is that it limits the damage an attacker can do if they compromise a container. Number 3, verification before deployment. This ensures that we're catching vulnerabilities before containers reach to production and in front of live customers. And number 4, runtime protection and monitoring provides visibility into container behavior, allowing you to detect and respond to suspicious activity quickly. So we begin our secure container journey at the most fundamental level, the container image itself. A Docker file starts with a base image, and our first choice here is crucial for security. We select the smallest possible base image, often the Alpine Linux or Alpine Linux if you're into Formula 1, which is less than 5 megabytes and contains far fewer potential vulnerabilities than larger alternatives. Next, we configure our application to run as a non-root user inside of the container. By the way, root access gives total privileges and control in a system. So if an attacker manages to exploit our application without root access, many attack techniques become more difficult or basically impossible to execute. And we also carefully audit every package and dependency, and we add it to the container. The attack service of our container would directly correlate with its contents. The less we include, the more secure our container becomes. With our minimized container image built, we move on to step number 2. Storing and analyzing it securely. Amazon Elastic Container Registry, or ECR, provides a managed service specifically designed for container images. After building our image locally, we push it to ECR, where it's stored with encryption at rest. ECR has built-in image scanning, which automatically checks our image against a database of known vulnerabilities, CVEs. And if our base image contains a critical security flaw, the scan report identifies it immediately. This gives us the opportunity to fix these issues before the container ever reaches a production environment. So rather than expecting developers to stay current on all security advisories affecting their dependencies, which is an impossible task given the volume, automated scanning provides consistent verification. This verification step embodies the security principle of trust but verify. We trust developers to write secure code, but we verify that their dependencies don't introduce any known vulnerabilities. Now, what individual security steps are good? A comprehensive cloud security approach requires connecting these steps into a consistent automated workflow. So step number 3, we'll use AWS code pipeline to help us stitch together each stage, retrieving code from a repository, building the Docker image, scanning for vulnerabilities, and finally deploying to production. And the real benefit here is that every time a developer pushes new code, these stages run automatically, ensuring no one forgets critical security steps like vulnerability scanning. So if code pipeline detects serious security issues at any stage, it halts the process completely, preventing insecure containers from reaching production environments where they could be exploited. And after our container passes all security checks, step number 4, we need to deploy in a way that maintains our security posture. Amazon Elastic Container Service, ECS, orchestrates how many container instances run and where they are deployed. In ECS, we define tasks that specify not just the container image, but the precise resources and permissions it requires. This is where we implement the principle of least privilege at the deployment level. We assign an IAM role to each task, granting it only the permissions necessary for the application's specific functions. And if our application doesn't need to read from DynamoDB, for example, we explicitly exclude that permission, and we only give access to what it needs. And if it only needs to write logs to CloudWatch but not read them, we will configure exactly that. By limiting privileges in this granular way, even a compromised container has dramatically narrower set of actions that it can perform. So we've deployed our containers securely. Is that it? Well, no. Step number 5, we need ongoing visibility. AWS CloudWatch captures logs from our containers in real time. If an application suddenly starts logging unusual errors, experiencing a sharp increase in CPU usage, we can investigate immediately. And this early detection of unexpected behavior helps us identify and respond to potential security incidents before they can cause significant damage. This creates a security feedback loop, allowing us to continuously improve our defenses based on observed behavior and real-world attack patterns. Step number 6, 6, with our secure pipeline in place, our work isn't done. It's just actually the beginning of a new phase. So once our basic pipeline is operating smoothly, we continuously refine and enhance it. We might implement stricter scanning rules as our security maturity increases, or integrate more specialized third-party tools for deeper static code analysis. And perhaps we add container runtime security monitoring that can detect unusual behavior patterns that might indicate an intrusion attempt. The first principal idea here is to continually limit the container's attack surface and improve our ability to monitor its behavior. And as we identify new vulnerabilities or security gaps through our monitoring or through industry advisories, we update our pipeline to enforce newly identified best practices. So, security is never done. It evolves as threats and technologies change. A container security pipeline isn't just a one-time project, but a continuous improvement process. So can you see how approaching container security from first principles, you create multiple layers of protection, each step with minimal images, non-root users, vulnerability scanning, automated pipelines, least privileged deployments, and continuous monitoring addresses a fundamental security requirement. We are integrating security throughout the container lifecycle and not as an afterthought, and that mentality will get you hired fast in 2025. Now, to build these projects that I've mentioned, you'll want to know all of the skills that a cloud security engineer needs. So click right here to watch my complete cloud security roadmap for 2025, detailing every single thing that you need to know.